Hello and welcome to the next lesson in the STEM Lockdown Digital School. This is grade 10 IT. My name is Karen Anderson and I'm hoping that we're going to learn something today. So this is lesson 14 and in today's lesson we're going to go over the books activity, which is an activity that I gave you in the previous lesson to complete. So I'm going to go over what you should have done for that activity. I'm going to show you the Delphi code for the algorithm that I showed you in the previous lesson, just to show you how you could take an algorithm written by somebody and turn it into a Delphi program. Then we're going to have a look at multiple conditions in if statements, which can be quite a difficult concept, but as long as you concentrate and are very clear about what it is that you want to achieve with these if statements, you should be able to write them correctly. And then I'm going to teach you about case statements. And case statements are the replacement for nested if statements using your ordinal data types. But I'll explain more to you when we get there. So first of all, this was the activity on page 63 of the Dandelion Delphi textbook, and you were told in the previous lesson to complete this activity, and now I'm going to show you what you should have done. So I'm going to briefly go through the question again, just in case you've forgotten what it was that you needed to do. So it was a program called If Statements that had lots of questions in it, and the one that you had to look at was at the menu option of book sales. You needed to retrieve the number of books sold by the user in an edit. Then you had to calculate the profit using the constants that had already been declared in the program, such as the once-off cost and the cost to print a book, and also then including what selling price was per book, and then calculate the person's income using profit is income minus expenses. So once you had calculated it, you then had to evaluate it using an if statement to display whether the person made a profit, broke even, or made a loss from however many books were sold. And here is an example of what your possible output could have looked like. So if they sold 100 books, they would have made a loss of 2,500 Rand. If they'd sold 200, they would have broken even, and if they'd sold 300, they would have made a profit of 2,500 Rand. So what did the code look like? So first of all, remember that these constants were already declared up at the top of the unit for you. Setup cost of 500, a printing cost of 50, and a sales price of 75. So again, I put this here just to remind you of what you needed to do. So first of all was the input, where you input, or the user input, the number of books that were sold. And then the profit needed to be calculated as number of books times sales price. So whatever the books were sold for would be the sales price times however many books were sold, minus number of books times printing cost, so that would have been how much it cost to print the books, minus the setup cost, which was your constant of 5,000. And then straight after that, you had your output of how many books, the number of books, which was shown in the previous slide with the sample output. And then you had to perform a nested if statement. So if our profit, the calculation that you made, was greater than 0, then output to the rich edit profit and what our profit was. Else, if our profit less than 0, then output the word loss and our profit. Else, in other words, your third option could only be that they broke even, so then you would output break even and our profit. So you would have a nested if here that tested if profit is greater than 0, otherwise if it's less than 0, otherwise, which is your only other option, that they would break even. And then the last step is to add an empty line underneath all of the outputs so that you could then output for the next set or number of books that were captured in the program. Right, then this was the algorithm that I showed you in a previous lesson, and the purpose of this algorithm was to take a date, given the year, month, and day, And this algorithm was then going to return what day of the week that specific date was. And in the previous lesson, I used the 14th of February 2021. And we worked through the logic of the algorithm, how it would work. Now, there's a sample of what the form could possibly look like, and here is what your code would look like. Now, I didn't, in this particular example, which was very naughty of me, use my variable indication names. So these names are not very meaningful. But what I did was I kept the names the same as what I'd used in the algorithm. But I should have had I year, I month, I day, I k, just to keep track of the data types of these variables. So let's quickly have a look at what Delphi code looks like. So first 3 lines are your plain straightforward input code to get from EDTY, in other words the year, EDTM being the month, and EDTD being the day, into Y, M, and D. Then this if statement here actually covers exactly what I'm about to explain to you in the rest of this lesson, which is an if statement with a multiple condition. So here my if statement had to say if M equals 1 or M equals 2, then M gets the value of M plus 12, increase the month by 12, and Y gets the value of Y minus 1. In other words, subtract 1 from the year. So this section of code here executes this part of the algorithm. And then the next 4 lines are just covering what these 4 lines of algorithm instructions cover. So k gets the value of y mod 100 is the same as that line there. And the only thing that you need to bear in mind when looking at this is this one over here has a 13 and then brackets month plus 1, whereas when we actually write out the Delphi code, we have to put the times sign between the 13 and the month plus 1. The rest of it, as you can see, was pretty straightforward. And then we had a nested if statement that evaluated if B mod 7 equals 0, then S day gets Saturday, else if B mod 7 equals 1. And so it went through all of the possible remainders to determine what day to display in the panel. Okay, so that's an example of how you would turn an algorithm into Delphi code. Right, now we move on to if statements that contain more than one condition. So, first of all, it is very, very important. When you have an if statement that has more than one condition, each condition has to have brackets around it. So each separate one between or on either side of the and must have brackets around it. If you're testing the same variable in your if statement, so like this example here is if I num is greater than or equal to 8 and I num is less than or equal to 12, you have to repeat that you're talking about I num. What do I mean by that? If you have a look over here, here are 2 examples of the incorrect code. So the first one has left out the brackets. Delphi is going to give you an error if you try and do that. You've got to put brackets around each one. The second one over here indicates how you think if I num is greater than or equal to 12 and less than or equal, greater than or equal to 8 and less than or equal to 12, I don't have to repeat that I'm talking about I num when I'm speaking English. But when I'm using code, I have to be specific. I have to tell my programming language what I'm talking about. So if I say if I num is greater than or equal to 8 and I num is less than or equal to 12, you have to be specific, because how on earth is Delphi going to work out what exactly you are talking about when you say put nothing in front of the less than or equal to sign? You could have 10 other variables in your program Delphi's not going to know which one you're talking about. So you have got to, even though you're still talking about inum over here, you have to repeat it again and say if inum is greater than or equal to 8 and inum is less than or equal to 12. You have to be specific. I've said this in previous lessons. Computers are dumb. You have got to tell them exactly what it is that you require from them. Okay. Right, then the next point underneath this is when conditions are separated with an and, all of the conditions have to be true for the if statement to be true. So in other words, if you've got a whole lot of conditions and it's if this and this and this, then the then will only execute if everything is true. So here's an example. The mark must be 80 or more and the subject must be IT and. So if I mark is greater than or equal to 80 and S subject equals IT, then. So the subject must be IT and the mark must be greater than or equal to 80, then the then will be executed. Over here is a truth table. And you can use this to evaluate the different conditions to determine what the output will be for the if statement. So if condition 1 is true and condition 2 is true, then your output statement or the result of your if statement will be true. But if any one of those conditions ends up being false, then your whole if statement will be false. So if condition 1 is false and condition 2 is true, your if statement is still false. So for example, if somebody's mark was less than 80, but they took IT, the then part of the statement would not be executed because both of them would not be true. Okay, so remember that. Then we can also have an if statement where an or separates your conditions. And when you have or separating the conditions, then only one of them has to be true. So you could have 10 different conditions in your if statement, but as long as one of them is true, your if statement is true. So again, here's your example. If either the mark is 80 or more, or the subject is IT, then your if statement will look like this. If I mark greater than or equal to 80, or S subject equals IT. That means the person can take any subject and have a mark greater than or equal to 80, or they can take IT and have a mark of anything. So that's the difference between and or. And if you look at your truth table here, you can see that if both are true, it's true. If only one of them is true, it's true. If the other one is true, it's true. The only time it is false is if both are false. Okay, so you need to be aware of that when compiling your statements with multiple conditions. So let's have a look at examples of how using brackets can also be important. And I'm going to go on to it just now as well. But let's have a look at these ones here, because here we have a mixture of and or. So in this if statement, it's going to be true for learners with an A or a mark over 80 or above, for both IT and English, or somebody that has an average above 90. So if we have a look, the brackets force this section to be done together. So if IIT is greater than or equal to 80 and I English is greater than or equal to 80, so those both must be true, or their average is greater than or equal to 90. So they've got to have over 80 or above for IT and English, or they have to have an average over 90. If, however, we swapped it around and we said if the IT mark is greater than or equal to 80, or the English mark is greater than or equal to 80, and the average is greater than or equal to 90, then only one of these two has to be true, and the average needs to be over 90. So they can have an IT mark 80 or more and an average over 90, or an English mark 80 or more and an average over 90. So the brackets are also going to change the meaning of the if statement. Here we've put the same stuff in, but because of where we've swapped the ands and the ors and where we've put the brackets is going to change what we're looking for. The other thing that you need to be very careful of is that when we speak English, we speak differently to the way we would say it in code. So here's an example. At school, you may hear somebody announce that all the grade 9 and 10 learners may leave early. Makes sense. Okay, if you hear that, you know that what that means is everybody who is in grade 9 or grade 10 may leave early. If you're putting that into code, you then have to use or, because if you used and in this if statement, if I grade equals 9 and I grade equals 10, then leave early gets true. It is impossible for one person to have an I grade equal to 9 and an I grade equal to 10. In other words, one child cannot be in grade 9 and grade 10 at the same time. So therefore, if you are evaluating, this is a person standing in front of me, you're going to say, is your grade grade 9 or is your grade equal to 10? Then you may leave early. But when you speak it in English, you're going to say all grade 9 and 10 learners may leave early. So look carefully when it comes to tests and exams, how they're phrasing it, because it could possibly mean that you have to phrase it differently in your Delphi code. Okay. And is evaluated before or unless you use brackets. So and or are almost like multiplication and addition in BODMAS. So and, if there aren't brackets, will be done first, so the same as multiplication is, and then or will be done. The way that I remember it is a very simple way, and you know what? It works for me. And starts with an A, which is earlier in the alphabet than O for or. So and is done first. So if we have a look again at these examples here, and I know that they're repeats of some of the other concepts, but we need to have a look at it anyway. I've got brackets around this second section. So even though the and will be executed first, I still put the brackets around it to force it, because it helps me to remember what's going to be done first. So this if statement here, as you can see is explained at the bottom here, is going to be if I grade equals 12 or I grade equals 11 and S subject equals IT. So it's going to be all the grade 11s who take IT or the grade 12s or children in grade 12. And again, if you have a look at how it's phrased in English, all grade 11s who take IT and all grade 12s. Okay, so in English I've said and, but in my if statement I've got an or again. This one over here, all I've done is move the brackets around. This one is if I grade equals 12 or I grade equals 11 and S subject equals IT. So therefore it's going to be all grade 11s or 12s who take IT. Or in actual fact, in English, we would say all grade 11s and 12s who take English, because that's the way we say it. But what we're looking for is if you're in grade 12 and you take IT, or you're in grade 11 and you take IT. Okay. Right, so here are some examples. You can have a look at these questions and then you can pause the video and see if you can get it right, and then come back and have a look and see if you have gotten it right. So the first question is, there's your variables that have been declared for you so that you know what you're dealing with. So you've got C gender, which is of type char, which means it's going to store an M or an F for male or female as the gender. You've got I grade, which is an integer, which is going to store what grade they're in. And then you've got S subject, which is a string, which is going to obviously store whatever specific subject you might be referring to in your if statement. So if we wanted to look at all boys in grade 10, what is your if statement going to look like? Okay, let me show you. It's going to be if uppercase C gender equals M and I grade equals 10. We want both of those to be true because we want all the boys in grade 10. Please note, we have discussed this before. We apply the uppercase function to make sure that whether they type a capital or a lowercase m, it's still going to evaluate it as an M, because I'm forcing the contents of the variable to a capital letter and then comparing it to a capital letter. Okay, and then grade equals 10. All the girls in high school. Now this one's a little bit more complicated. You need to think girls is pretty simple, but how do you check using these variables whether somebody is in high school? I'm going to pause for a second so that you have time to hit pause, and then we'll have a look at what the solution should be. Right, the solution is if I grade in 8 to 12, remember in, we did it in a previous lesson, and uppercase C gender equals F. Okay, notice the brackets around each condition, and here I have applied my in, because if I didn't use in, I would have if I grade equals 8, or I grade equals 9, or I grade equals 10, or I grade equals, you get the picture. Okay, I would have a very long if statement. Whereas what I can do is I can now say if I grade in 8 to 12 and uppercase C gender equals F. Okay, next one. All grade 10s who don't do maths. And it is if I grade equals 10 and S subject is not equal to maths. And I'm hoping that you're looking at this if statement and you're thinking to yourself, hang on a second, there's something missing. What is missing is the uppercase function to be applied to S subject. So this should have read, and uppercase brackets S subject not equal to capital maths. So maths should have been written in all caps, because then once again, as I've explained before, it wouldn't have mattered how this person typed maths in. It would have still recognized it as maths. The case wouldn't have been a problem if I'd used uppercase to convert S subject to all caps. Okay, so there are some examples of some if statements using multiple conditions to answer certain questions. Okay. Right, so now we move on to the case statement. Now the case statement can be difficult to remember, but Delphi actually gives you some of the skeleton code, and hopefully once I've explained it, it'll make it a little bit more easy to remember and understand. So first of all, a case statement can only be used with your ordinal data types. Okay, so only integer and char. And this is the basic outline of what a case statement looks like. So it would be case, variable, only an integer or a char variable of. Value 1, so that's what you're evaluating. So if, for example, my variable was I grade, I would have case I grade of 8, and then colon, and whatever statements I want to execute if I grade equals 8. Then I would maybe have 9 over here, colon, and whatever I wanted to happen if I grade equaled 9. And then I would have 10, 11, 12. So I can have, this is my integer or char version of a nested if statement. I can have different things happening depending on what the value of this variable is. A case also has an optional else. So you don't have to include an else. You can leave this out completely, or you can put an else in. And then the last thing, which I'm going to repeat myself on the next slide, but it's always good to hear it again. A case statement has an end, but no begin. Okay, so the end indicates where the case ends. But every line in your case statement has a semicolon in it. So let's have a look at this example over here. So the only thing that this case statement does, and there is a Delphi function that does it for us, that will return the name of a day dependent on what number we send. Okay, but this is just to show you how this could work. So I read in a number from my spin edit into iDaynum, and then I go case iDaynum of 1 colon sday gets the value of Monday, 2 colon sday gets the value of Tuesday. So what it's saying here is if iDaynum is 1, then assign Monday to sday. If iday equals 2, then assign Tuesday to sday. And so it goes on Wednesday, Thursday, Friday, all dependent on what number iDaynum equals. And then included in this one is a little bit of validation that says else sday gets the value of invalid. So anything other than 1 to 7 that gets put into iDaynum is going to then place invalid into sday. So if we were then going to output sday, let's say iDaynum equaled 4, it would say today is sday would be Thursday. If it was 9, then it would output today is invalid. Okay, so it just doesn't really matter, but just to show you that that's how it would actually work. Right, so let's have a look. What I've done here is I've shown you what a nested if statement would look, which did the same thing as what a case statement would do. So our input is the same, but with a nested if, I have to say if iDaynum equals 1, then sday gets Monday, else if iDaynum equals 2, then sday gets Tuesday, and so on, and in and if and else and if and else and else and else. Finally, I have an else invalid day. Okay? Whereas a case statement, as you can see, the blocks are the same size, but the text is bigger for the case statement because there's actually less typing. And it's easier to see what's going on for each of these options. Okay, so this is exactly the same code, or the same logic, using different methods of code. And when we're dealing with an integer, it's much easier to put it into a case statement. Right, let's have a look at a few more rules. Remember, I have explained quite a few of these rules to you already, but I'm going to repeat myself. Case variables may only be ordinal data type, so only char and integer. I know that Boolean is also an ordinal data type, but there's really no point in doing a case statement for a Boolean because you only have 2 options. So you may as well just stick with a regular if. If it's char, we need to use uppercase to ensure that the program is not case sensitive. So here's a char example. So here I've got case, uppercase C answer of. So C answer is my variable that I am evaluating. And here my case statement is saying convert C answer to a capital using uppercase. Then if it's an A or a C, then output correct answer to the label and increment the I correct counter. So this is adding 1 to the number of correct answers that the person may have gotten. So wouldn't it be lovely if all of your multiple choice test questions from now on had, if you answered A or C, you got it right. and if you answered B or D, you got it wrong. Obviously, that's not the case, but this is what this particular case statement is saying. If capitalized C answer equals A or C, then yay, you got it right, and we add one more onto how many you got right. If the C answer is B or D, then we output incorrect answer and we increment how many incorrect answers you've got so far. And then the case statement also has an else. So if it's anything other than A, B, C, or D, it's going to output invalid answer and it's going to increment the number of invalid answers. So this case statement will only either give you a correct answer or an incorrect answer if you entered A, B, C, or D. Anything else, it's going to go invalid, and we ink the counter for invalid. Okay. Also, please note, just like with the in operator, when you're dealing with characters, each character has to have quotes around it. So A gets its own quotes, comma, C gets its own quotes. And then also please note that because I've got more than one thing that I want to happen, if C answer is A or C, this more than one thing has to have its own begin and end. So the same as with an if statement, if I've got more than one thing that needs to happen for an if statement, I start, then begin, whatever my code is, end. Same thing happens with a case. Okay, so you've got to pay attention because now my case has an end and it's possible that my different options are going to have their own begins and ends as well. Okay, so now we're starting to get very bogged down with all the begins and ends. So as I've said, case statement has an end but no begin. No options can be repeated. So I cannot have, if we look at this number example, I can't go from 1 to 8 over here and then again from 8 to 12. I can only ever make something happen for a particular option once, because otherwise again I'm going to have an error. And the next thing that you need to be aware of is that case statements will only go to one of the options. So it's never ever, so it's like an else, if then else, it's never ever going to do both of these options. It will only go to whichever one of them is true, whether that's one of the options or if it's the else. But it's only ever going to execute one of them, and you can never, so I couldn't even have a 9 as an extra option here because it falls in between the 8 and the 12. So you can never ever repeat a particular option in a case statement. Okay. Right. Few more things to have a look at using our same examples. You can have a range of options similar to what you would have in the in operator. So here we've got them, 1.7, same as what the in operator would have. So for consecutive values, like with the characters, again, you can have A.Z, each with their own quotes around them, same as what you've got here, but now it's anywhere between A and Z, something's going to happen. For non-consecutive values, just like with the in operator, you separate them with commas. So if this wasn't 1 to 7, it could have been 1 or 3 or 7, and then I would separate them as you see here with commas. Okay? If the case variable is an integer, there are no inverted commas around the values. If it's a char, then there will be inverted commas around the values or quotes. Okay, so just like you see here, I grade is an integer, so I'm looking from 1 to 7 and 8 to 12. C answer is a character, so I'm going A or C, each of them with the quotes, or B or D, each of them with the quotes. And just like I said before, I want to make sure you understand, I can't put A over here with B and D as well. It can only appear in one of the options. Okay. Right, now it's your turn to try. And this you're going to, it's in no textbook. The only place it is in this PowerPoint presentation. So you need to have a look at what's being asked here. You need to create the program yourself using the components as they are listed here. So I've given you a screenshot of your structure so that you can see what to call the different components. And I've given you a screenshot of what the form should look like. So you've got a spin edit where the user is going to enter the number of hours worked. And then you've got a calculate amount button that's going to look at what. So the question is, Lawrence runs a garden service and his rates are given in the table below. So 1 to 2 hours per week, his rate is 250 Rand an hour. 3 to 4 hours per week, his rate goes down a little bit, then it's only 200 Rand per hour, and so on and so forth. So what you need to do is create the following interface to calculate and display the amount in rands that Lawrence will be paid for the number of hours his service has worked. So his garden service works for a certain number of hours. I'll give you an example. Let's say, for example, he enters that his garden service worked for 3 hours. It means that his rate per hour is 200 Rand. Therefore, the total amount of money he's going to earn is going to be 600 Rand because it's going to be 3 hours times 200 Rand per hour. If he works more hours, it's going to be less per hour, but we don't want the per hour amount. We want the total amount of money he will earn for those hours. Okay, and you need to use a case statement because I'm reading in the number of hours as an integer. So if you're watching this now, it's a good idea to pause it, create the program, write the code, and then you will see the solution to this activity in the next lesson. Then another one to do in the Dandelion Delphi book on page 67 is also in the if statements activity. And here you need to look at the gym menu to be able to answer the question. So you're asking the user to input their height from the edit, indicate whether they're a Vitality member using the checkbox, and then ask them for their current weight using a dialog box. And we've discussed what a dialog box is. Then calculate their BMI, and then you need to work out what their monthly membership cost is. Now I'll give you a clue. This is working with percentages and real values, which means you cannot use a case statement. You will have to use an if statement with multiple conditions because you're evaluating whether the checked property of a checkbox is true, and then you're evaluating what a person's BMI is to work out what their monthly membership cost will be. So you've got a nested if with multiple conditions in it. And once again, you will also get the solutions to this activity in the next lesson. There's the rest of the question that it needs to be answered. You can see that again you're going to use a dialog box that's a show message this time to indicate to them whether they have a discount or what their discount is or what their member number is, and then you're going to output what they're paying, their weight, their height, and their BMI. Right, so what have we learned in this lesson? We've learned that you can have multiple conditions in an if statement using and or. Case statements are conditional statements that can be used with integers and characters, only integers and characters because they deal with ordinal data types. And then here are the links to either the Dandelion Delphi book, if you would still like to purchase the ebook version of it. Otherwise, you can at least just get the data to be able to complete some of the activities that I've given you in these lessons. And then to get the schedules for the Africa Teen Geeks lessons, you can go to their website and find out or click on get the links for each of the live lessons that are happening. In the next lesson, I'm going to go through the solution to the gym activity. I'm going to show you the solution to the gardening activity. So that's Lawrence's fees and how much he's going to be paid. And then I'm going to show you radio groups, combo boxes, and list boxes, which all work in a very similar way and tie in very nicely with case statements. Please don't forget to go to the YouTube channel for Africa Teen Geeks if you want to catch up on some of the lessons that you might have missed, and follow us on social media for all the news about what's happening with Africa Teen Geeks and the STEM Lockdown Digital School. Thank you for listening, and I hope you've learned something. Goodbye.